Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 8 from the October-November 2022 IGCSE Cambridge Paper 4 Variant 1. This is 0580 syllabus. Here we have a diagram which shows a triangle ABC on horizontal ground. Okay, AC equals 15 centimeters, BC equals 8 meters, and AB equals 20 meters. BP and CQ are vertical poles of different heights, 3 meters and 4 meters. AQ and PQ are straight lines. So this is a three-dimensional diagram. It's like these are coming out of the page. This is on the horizontal ground, and these are vertically upwards. It's as if you can think of CQ coming out of the page. It's three-dimensional. Okay, it's not like a 2D diagram, right? So it's a three-dimensional. You've got to imagine that this is the floor, and this is coming out of the page going upwards. And same with this. All right, so these are like vertical. This is a vertical triangle. This is a vertical trapezium, and here we have a floor which is horizontal going along the floor. So you got to imagine this in 3D. This is 3D trigonometry. So it says show that the angle ACB is 117.5 degrees to correct to one decimal place. All right, so that's just this triangle that's on the floor. So this angle here, we got to show that this angle here is 117.5 degrees. All right, so it's like this is a wall meeting another wall, but they don't meet at right angles. Okay, the walls meet at an angle. So this floor here, it's like a room that's got a side and then the other side, but the walls aren't like exactly meeting at right angles. There's an angle between them. That's not a right angle. So we've got to find what that angle is. So let me call that angle theta. Now, when we have to find an angle in a non-right angle triangle, and we know all three sides, well, that's classic case of cosine rule. The cosine rule, when we're finding an angle, is the cosine of A equals B squared plus C squared minus A squared over 2BC. That's the general formula that you learn, right? The formula for the length is A squared equals B squared plus C squared minus 2BC cosine A. They're both basically the same formula, just this is rearranged to make cosine A the subject. So if you think about it like this, it makes life easier when you're trying to find an angle, but you must know all three sides. And you don't go by the labeling of the triangle. So I'm going to kind of like ignore what these labels are for now, because I don't want you to get confused by them, right? Don't think about the labels, think about the concept. Okay, this angle that you're trying to find and this side must be opposites. They must be opposites. So if I'm trying to find this angle over here, I have to use 20 in that place. And the other two places, B and C, can be either of these two switched around, it doesn't matter. But the 20 must be in place of the A in my formula. So if I was finding this angle, then that would be my A. If I was finding this angle, that would be my A. But I'm finding this angle, this is my A. So it's not according to the labels on the triangles, it's according to the concept. Very, very important. So I can say that the cosine of the angle I'm looking for, which I've called theta here, is equal to, you got 15 squared plus 8 squared. 15 squared plus 8 squared minus 20 squared. Minus the length opposite 8 squared. Over 2 times 15 times 8. Okay, that will be cosine theta. So that's enough to show your steps. You can say theta is equal to, now make sure your calculator is in degree mode, which it is. I can put inverse cosine, and I'll put all of this in now. 15 squared plus 8 squared minus 20 squared, all right, over 2 times 15 times 8. Okay, close that bracket. When I press equals in degree mode, it will give me the angle 117.5485. 117.5485. Now we're going to show that it's correct to one decimal place. So you should always write it to more decimal places than you need. And in the end, you say, therefore, theta equals 117.5 degrees. So ACB is 117.5 degrees to one decimal place. And so there's the answer to part A. Now, part B says, find the area of this triangle ABC. Now, to find the area of a triangle that's not a right angle triangle, we use the formula that the area is equal to a half times AB sine C, where A and B are two sides that make the angle that you know, and sines the C is the angle that you know in the triangle. So you need to have two sides of the angle. So I know this angle now, and I have to use these two sides as my A and B. I can't use the 20 as my A or B. I have to use the two sides that make the angle that I know. And I know this angle now. So I'm going to do a half times 15 times 8 times my angle that we know here. So it's going to be, the area is going to be a half times 15 times 8 times the sine of this angle, 117 point. And I'll use it in its more accurate form, okay, which is in my calculator already. So I can just put a half, okay, times 15 times 8 times the sine of my last answer, which was the angle that we found. And that gives me my area, which is going to be 53.197. So that's 53.197. It doesn't tell us how to round it. We should round to 3SF. So 53.2. So that will give me 53.2 meters squared. There's the answer to part B of this question. So this is quite simple. It's just about this shape on the floor. So we haven't really got into the 3D part yet. Now, the next part of the question is question number 8, part C. It says, calculate the length of AQ. Okay, AQ is this length over here. Now, I've just taken the snippet of the diagram that we needed. Now, this is like the vertical triangle. It's a right angle triangle. That's 15 and that's 4. Okay, so we can use Pythagoras for that. It's pretty simple. We can say AQ is equal to the square root of, these are both the two shorter sides, so you have 15 squared plus 4 squared. Okay, so I can write it down in its exact form first. So you got the square root of 15 squared plus 4 squared. That gives you the square root of 241. And we round my answer to 3SF, which is 15.524. 15.524, so it's 15.5 meters. That's the length of AQ. All right, so that's the hypotenuse of this triangle. Then it says calculate the angle of elevation of Q from P. So now we're going into the 3D stuff here. So the angle of elevation of Q from P. So if we think about P and drawing a line which is horizontal. Now, horizontal meaning it's like, remember we've got 3D shape here. So the line, the angle we're looking for is this angle over here. This is the angle we're looking for. Okay. Now what I'm going to do is I'm going to draw that triangle over here. So I'm going to draw, this is like where P is. I'm going to just make a little sketch as if we're looking at it from this angle here, right? So that's P and that's Q. Okay, and this point, let me just call it the point X. Okay, this is the point X. We're looking for this angle. This is the angle of elevation of Q from P. So we're at P. Okay, we're looking horizontal. Then we have to move upwards until we're facing Q. The angle that we go through from the horizontal until we're facing Q, that's the angle of elevation. Right, so this is the angle. Let me call it angle X, small x. Right, so how do I find this angle? Well, I know that this length from P to X is parallel to this 8, because it has to be horizontal. That's going to be 8 meters. Okay, PX and BC are both the same length. Right, and I know that from P to P is 3 meters, and from C to Q is 4 meters. So this length here, this is 4 minus 3, which is 1 meter. So here we have 1 meter. So I can use tangent. I know that this is a right angle, okay, because this is parallel to that, so that's a right angle. So I can say that the tangent of the angle I'm looking for is equal to opposite over the adjacent, so it's 1 over 8. So x equals inverse tan of 1 over 8. So we can just use simple SOHCAHTOA trigonometry because we have right angle triangle. So inverse tan of 1 over 8, and that gives me 7.12501. So 7.125. Now, angles should always be given to 1 decimal place unless otherwise stated. So I write 7.1. Okay, so here you have to be careful. Many people write 7.13. Angles should be given to 1 decimal place. And strictly, they could take marks off if they wanted to. So be very careful. So this is angle of elevation of Q from P. Okay, now for part E, we have tells us about another straight wire. So we have a wire going from P to Q and a wire going from A to Q. There's another straight wire that connects A to the midpoint of PQ. Okay, so it connects A to the midpoint of PQ. So it goes right from A till somewhere over there, which is the midpoint of PQ. So like those two sides are equal. Let's call that point M, the midpoint of PQ. There's no other M's anywhere. All right. Now it says calculate the angle between this wire and the horizontal ground. So we've got to find the angle between this wire and the shaded plate part, which is the ground. Okay, so it's the angle between a line and a plane. Now, the angle between a line and a plane is the angle between that line, and you could say the shadow that that line would form on that plane if there was a light shining from above, directly above. Or if you were to drop this line, it would fall vertically downwards. Okay, the place where it falls on is the angle between that line and the actual line as it originally was. So what I'm going to do is I'm going to draw a little, put it in a different color, a little shadow of this line on the ground. Okay, so that's going to go from there to there. Directly below M it will fall. Okay, so that's going to be like directly below M. It will form like this right angle triangle. It's a right angle because this meets the floor at right angle. This is vertical, this is horizontal. Right, so you have this triangle and you've got these points here. Now I already called the point here X in the first thing, so let me call this point something else. Let me call this point let me call this Y. This point here Y. Okay, so we've got this right angle triangle which we need to use to answer the question. So if I just consider this right angle triangle, here we have A, here we have what we call Y, and here what we call M. Right, this is a right angle. We don't know any lengths, but what we need to find is the angle here, this angle here. Let me call it the angle alpha. This is the angle between the line and the plane. Okay, so that's the angle we're looking for. Now, right now, we don't have any lengths on this triangle to help us find this angle. All right, so we need to find some of these lengths. So I'm focusing on the length AY and the length MY. All right, let's look at MY first. We already established something in the last question. We had this line going from P to this side, and we call that point X, I think, in the earlier part of the question. Okay, so you know this line here, PX, forms this triangle, which is a right angle triangle that we looked at earlier, and we established that this height is 1. Okay, this height is 1. Okay, so what I know that the height between here and here is 3. Between here and here is 3 because this is the same height as this. Then we got this section over here. Okay, now this section over here, if I look at this triangle, I'm going to look at this triangle now. Okay, this triangle. Okay, which is the same triangle up here. This is the same triangle that we got up there. Okay, so this triangle that we used earlier, okay, this is PXQ, this triangle over here. I'm just looking at it from here. Basically, we know that this M, it's not actually drawn so well. So let me just draw this so that it's a bit more. This is exactly halfway along there. And what we will be able to see is, let me just make this a bit more realistic. Okay, so our M is halfway between P and Q over here. That's where M is. Okay, so that length is the same as that length. We don't know what that length is. And then you got this line coming straight down. Okay, this line coming straight down, which goes down to Y. Right, that goes down to Y. Y is at the bottom here. Okay, Y is at the bottom here. Right, now I know from Y to this point here, I know that's 3 meters. Okay, so Y to somewhere up here is 3 meters. Then I've got this extra bit. Now I know that this triangle here and this small triangle, this big triangle and this small triangle are similar triangles because they both have a right angle and they both have this angle here. So P and this point M and PXQ, they are similar triangles. And I know that the ratio of the lengths is 2 to 1 because this is half of that. like PQ is twice the length of PM, all right? Because M is the midpoint of PQ. So if they are similar triangles, that means from there to there is 4, and from there to there is also 4, because it's 8 to 4, right? And also, if this is 1, so this length is 4, this length is 8, this length is 4. So this length PX is double P to this point. And this height here, the height of this triangle, must be a half of the height of that triangle, because they're similar triangles. This is twice the height of this. So that's from there to there is 1 meter. So from there to there must be 0.5 meters. So I know that you got 3 plus 0.5. So the whole of the length from Y to M, that must be 3.5 meters. So we use similarity to figure out that that's 3.5 meters. Okay, so we know the length from MY, right? This length MY, okay, which is 3.5 meters. So in this triangle that I'm looking at here, that's one of the lengths. Okay, so we worked out what this length is here using this triangle, and we know this is already 3 meters. Okay, because that's horizontal, so it's like a rectangle down here. So if that's 3 meters, that must be also 3 meters as well, right? And now we have to find out one length. Now this 15 belongs to this side here, by the way. So this is not 15. We've got to figure out what AY is. Okay, now if we look at AY, not AY, yes, Y is over here. I'll call that point Y. If I look at this, I know this angle from the first part of the question. I know what this angle is, right? So what we have here is you can say a triangle, which I'm going to draw as if I'm looking from above. A triangle like this. Okay, here we have A, here we have C, here we have Y. I know that this is 15 meters, and I know that this is 4 meters. I know this is 4 meters from here to there, because this is the midpoint, right? If that's the midpoint of that, the midpoint of that, the midpoint of that. So that's 4 meters. And I know this angle from the first part of the question. This angle was 117.5485. 117.5485 in this exact form. More exact form. 8545. Okay, so that's the angle over here, angle C. All right, so to find AY, I can use the cosine rule. Okay, so to find AY, I know AY is equal to, we have A squared plus, remember the cosine rule is A squared equals B squared plus C squared minus 2BC cosine A. So AY will be the square root of, you got 15 squared plus 4 squared minus 2 times 15 times 4 times the cosine of the angle between those two lengths, which is 117.84. Was it 8545? 0.5485, sorry. 5485. Not 8. .5485. Okay. Now we're using the cosine rule because we have two sides in a non-right angle triangle, and the angle between the two sides, we want to find the side opposite. That's classic use of the cosine. Okay, so putting this all into our calculator, what we find is that we're going to put the square root of, we have 15 squared plus 4 squared minus 2 times 15 times 4 times the cosine of, and the angle, I've now stored it in the calculator as A. Okay, so that's the angle that we had, 117.5 from the first question. Now if I press equals here, it should give me my answer, which is 17.219. So AY equals 17.219. So now we have this side, which is 17.219. So now we can find the angle. We know the tangent of the angle. This is the angle we're looking for in this question, is the opposite over the adjacent. So 3.5, which we found earlier, over 17.219. So alpha is equal to the inverse tan of that. So we're going to do inverse tan of 3.5, and I can just put divided by the last answer, which was the side we found. And that should give us the correct answer, which is 11.4895. So 11.4895. Now we're going to round our answers to one decimal place for angles. So it's 11.5 degrees. So there's the answer to part C. Part E completes the whole of this question. This question, which is question number 8 from the October-November 2022 IGCSE paper from 0580. Other questions from this paper can be found in the playlist that will appear in this region over here. Other questions from this topic of 3D trigonometry can be found in the playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.